Hi, welcome to another PlayBASIC Live little video. I think we might look at something a bit more, well, another one of those kind of areas of PB that's not understood very well, and has to do with types and arrays in general, actually. I'll assume that you know what an array is, so I don't have to explain that stuff here. I just want to go through some of the kind of quirkier things you can do with them. So you might know that you can create integer arrays. I'll call this, my int array or something. Give it a size, and it's a one-dimensional size. Now, what's actually happening when we do this is that when the compiler comes down through the code here, it sees the dimension statement and goes, okay, we're creating a new array, or we're either resizing an existing array. If this keyword here is unique, it adds it to our array. It checks to see what kind of type this is as well. And if you have no hash after it, or if you have no string, it becomes as an integer array. Hash would mean it's a floating point array, and a string is a string array. And that's kind of in keeping with basic of old, so it's not that much of a change. So the question is, when at compile time, all the compiler knows is that we're creating an array. It doesn't actually know the size, which might surprise you, because this value in here can be a literal like this, or some variable. Might have a variable called size, which somewhere else in the code you might declare size is 200. That might be 100 lines above or 500 lines. It doesn't matter where it is. I'll get rid of that hash so we're actually talking about it. I have sync. If we just run this in debug, oh no, this might actually not work that well in. Yeah, I missed that. I've already laid the debugger out this sort of fashion where I've got the PB window here and the debugger window here. Hit stop, and you can see our variables in our main scope. If you click on the variable, you get a look inside it. It's telling us that this is my array, and it's currently 200 size. Its type is integer. Its physical size in bytes is 804, because there's not just your data, there's some other information tacked on the front of the information as well. And different types of structures have different size headers, I guess. And the bank here is really should be handle, which would make more sense to people, I think. So it's this piece of memory here that's being representing our array is stored internally at handle 23. Those handles are how the PlayBASIC runtime, the VM, the virtual machine, keeps track of all the allocations that your program makes. You never actually get a pointer to anything. You actually get handles, and you query the handle to see what it is and where it is in memory if you have to access it. If we scroll through, we can see the contents of the array at this point, which is empty, as we would expect. Now, we can kind of pass these things around. So if I had a function over here, this code's not going to be very useful, I just want to get the ideas out there. Let's say this is a fill int array. And we give a stub. I'll go over this. Okay, so I'm going to assume that you know what a function is. I don't have to explain this to you. We've got our function name, and our first parameter here, notice how we've got, I've called it me, and we've got the closed brackets after it. Now, in PB terms, that is basically an array stub. At this point, it doesn't know how many dimensions the array is going to need, but it can glean that this is going to be an array coming in. It's going to be passed in by handle. It's going to be of integer type and called me. Beyond that, there's no idea. So in here, we could do things like so I can run through all the indexes in the array and assign them some, I don't know, some random value or something. No, I'll make it a bit more obvious what's going on. We'll have our fill value. Let's call it that. Those with a keen eye will know there's actually a command in PB to do this very task. So you would never do this like this, but that's our function. So what's happening is where it can accept an integer array passed in by handle, and when we pass by handle, we're not actually copying the contents of the array, we're just copying. I think I run the debugger here, hit stop and go to variables. We're copying the special handle number, which is termed bank here in the debugger, copying that across. There's a bit of a bug in there somewhere. If we look inside the int function, the fill int function array, nothing's been actually declared or used. The debugger lets you look at your entire program all the time, by the way. You're not just looking at, so you actually see what's going on across things. You might find that a bit weird, but it's really a kind of a state monitor, to be honest. Alright, so let's call the function fill int array. We'll pass it my int array. We'll give it the double quotes. So this means that tells PB that we're passing this thing, this entity, this array in this case, by its handle into this function as a parameter. I think at the end there it's got a fill value, say 255. If we run this in debug again, hit stop, we go to my array. Now all our values are filled 255. But if we go to, we peer inside my int array here, we should be able to see. It doesn't refresh that. I'm running PB165 and the debugger is actually from the older version of PB and they're not quite compatible as yet, but it's a bit of a pain. But we'll make do. So we can look at what the state of the fill value was of when this function exited, what the state of loop was, and what the contents of that internal array are. So I'm talking about this bit of code here. So when we call this, our array has been passed in, and the kind of magic number, the handle, has been passed in. It's just one integer. It's inserted into this local array here, and then we're just operating upon it in here. There's one problem with that mechanism, and that's if you try and redimension this array in here and not pass it back, you might get some strange behaviors. It's possible for those things to change. I can't think of a good example where it would, but okay. So I can pass an array in by handle, but I can also do something weird. I can do this. I can make an integer array. I'm just using 1D arrays because I'm too lazy. What do we call it? We'll call it just me, I guess. Same thing. So functions have input parameters here and output parameters go after here. You can have multiple parameters coming out of a function, but most of the time you'll only ever have one function coming out. If I do dim me size. If I call this function, I'm going to be creating an integer array in the local scope inside this function, and then I'm going to be returning, passing its handle out to whatever called it. I'll see if it lets me assign that back to here. I just have a variable called handle. How big will we make it? We'll make it 4096 in size, and we'll print the handle to the screen. It's just an integer, but that integer is representative of the allocation that array takes inside the virtual machine. That's how we can work out if you give it if a handle is good or bad. That looks pretty useless, doesn't it? But you could do some pretty weird things with this kind of functionality. You could make like a staggered array, for example, or you could use it with the what's called the make array command, which is kind of another unusual command. What are we going to call that? I'll just call it array for now. Now, make array with dimension statements. These things actually create a pattern for this array inside the compiler. So the array has kind of a signature about it. We know its name. We know what kind of type or data type that the array is, and how many fields it has, how many dimensions it has, I should say. This is a one-dimensional array. When we use make array, we actually we don't want to give it any of that. We just want to effectively add this name to the compiler's local scope, and then we can do this. Array equals handle. Now, for all intents and purposes, the array that was created in here, array here is now this array. So if I did, I better fill that in with something, but no. I'll get rid of some of this stuff here. Let's get rid of that. Get rid of that thing there. So we're just looking at how we can use make array, then access the contents of it, and we'll do something a bit more freaky with it in a second. So we'll dimension the array here. We'll call our filling function. We'll fill it with I don't know, some value. 1, 2, 3, 4, 5, 6. So every cell inside the array is going to have that value in it. So if I go for loop equals 0 to get array elements, I query that of the array. There's a second parameter there for what dimension you want to actually get for, but by default it gets the first dimension. And we go print array loop. We might want to make the array a bit small. Let's make it 16. Right. So the bit of code here is going to call this function. It's going to dimension an array of however many integers this is telling it to. It's going to fill that array full of every item in the array with this value, and then return the handle. I'm grabbing the handle here, and I'm registering an array stub in the compiler using the make array, and I'm just assigning that the handle. Now, when you create a stub like that, it doesn't own the data it looks at. So if I assigned another handle to it, you're not destroying anything. You're just looking at something and then reusing it for something else. There we go. Look at the debugger. So we'll hit stop, go to variable, my array is the redirection array, and it's looking at bank 23. And when we called make integer array, that should be the handle that came out. Oh no, it's been cleaned up since then. Yeah, there's a few problems with the debugger on this build. I have to fix those. And I think, well, why would you want to do that stuff for? What if you wanted an array of arrays? You know, if I can dynamically create an array here, I don't have to run through and I don't ever have to run through and, do a bunch of, dim, I don't know, I have a whole bunch of animations, anim1, anim2 or something, and so on and so on. It's probably practical to do it like that if you've only got, a few of them. But if you have lots of them, not really, no. We can make, just to demonstrate this a bit further, we could do this with, we can make another array here of 256. And I'll just assign it, I just assign that straight to our stub. So I'll fill the first array in, and doing it here. We are going to lose track of the handle when we do this. When we overwrite the stub, it doesn't undim whatever was there, it just actually replaces it. So it's the same as using an integer. If I copy, if I do something like this where I go, A equals B, whatever was in A previously is not destroyed. It's just written over. I can't actually just get it back, but yeah. Right, so we can sort of create arrays inside functions, return them, do that kind of stuff. I'll leave that bit there. Let's say we had, I'll call this thing, oh god, container. Give it some size, I don't know, size equals, 16. Trying to make this nice and obvious, but maybe it's not. This thing here, this doesn't, make array doesn't generate any execution code at runtime, by the way. It's just, we're just adding this to the compiler name, to the array list in the compiler at compile time. So otherwise we wouldn't be able to access the thing. It wouldn't know what array is. So here, let's have a random range between, I don't know, 50 and 1,000 values. And when we fill it, we'll just get, or randomize whatever that fill value is, just so we get some different data inside the array. So this thing here is going to create an array, and then we're going to store it, so we can keep track of these handles at a later point. Loop. Oh, I'll just get rid of that for now, actually. Yeah. Right, so now I'm actually creating conceptual arrays of an array. Don't need to make array there above it. Just comment that out for a second. You won't be able to see them. The debugger has no understanding of what's going on. It says container, it looks at container, it goes, oh, this is just a bunch of integers, and if you look at the numbers in there, they do appear to be just integers. we would need like a special array type for this to understand what we're actually doing. Of course, what I could do now is I could go through here. I'll actually look at the contents of the arrays. So we created the array last time we were in that function above. This time I'll grab the handle at this point and write it into here. Now we probably should do something like, get array status to make sure this thing actually exists. Because if we can pass anything into this array, and we might get some ugly results if we pass the wrong thing in. I don't know. We'll run through its size. Get array elements. Array. We'll just grab a string and stick all the values in that. That'll do. Hopefully that'll do for you. So plus equals, convert the whatever we're reading to a string and stick on a comma at the end, and then drop this thing here to the screen. How we go on? Oh no, I've got the wrong. I want that loop counter there. So there we go. Now the arrays are too large. I'll make them smaller so they sit on screen. So this time they'll only be between 5 and 10 elements long. That's better. So we've got these. We're treating them like we've got these different sized lists. If you wanted to, you can make all the array functions work on these stub arrays here. So once you've grabbed the handle from wherever you stored it, you can manipulate them, however you want. And then if you want to delete the arrays at the end, you can't just undim the container. It has no idea. It just sees container and goes, oh, that's an integer array, and cleans up that memory. It won't clean up these arrays we've dynamically created. So you would need something that goes through and does this task here. I'll put this in below there. So this bit of code here would undim container. Oh, caps lock's on again, is it? Yeah, let's get rid of that. Okay. So then we go undim our array, and that would clean up that memory, and oh, did I delete something? Yeah, probably did. So a little bit more work it's involved in doing this kind of structure inside a structure kind of stuff. But this is what this make array command's for. And this works with type arrays, lists, all kinds of stuff. It's not limited to just this. Run in the debugger. So if our application is run, let's have a look at the state. Our VM cache is down to 22, so we might put a break there. Then we'll look at the state. I'll put breaks around those things there actually. So what we should see is go to state. Our program is halted. So we've got 41 allocated handles inside the VM. If I hit run again, where in the code are we? We've moved past the delete containers onto the next one. State's down to 25, back to program, and they're still running. So we've undimmed container, and we are back. There might be a bit of a bit of unknown in there. The loop here is working fine. The undim itself, I'm not quite sure if that was working properly. It's hard to tell because actually handles are allocated doing things in the background. Sometimes strings, temp strings, generate handles, and they sit around through the program's entire execution. So you might see something, but actually that buffer is being used. Maybe things like string operations can generate temp handles, for example. Alright, so there you go with a bit of a look at one of those kind of stranger features that you can do in PlayBASIC. We'll just try one little change. If we had oh no, might take too long actually. Our container, make array. Yeah, we'll have go at a typed array. Same principle, by the way. I normally just have these prefixed with type. Just call it object. Character or something like that. Oh no, my dude. And my dude character can have a status field and can have like an X and a Y coordinate or something like that. And what the sprite it's using, and I don't know. Most games are going to have probably 20 or 30 fields for what characters you're doing. It is the same principle. So let's change this up a little bit further. Let's make a function. So make my dude array. Probably not the best. I probably should have something like vectors though, shouldn't I? Yeah, until vector 2D, we'll call it. Pretty boring stuff. So these are going to have two fields. It's going to have, we'll call it me. Me, it's an array and it's of type vector 2D, which is it's returning a handle of this type here. And it needs to know that the type here, because of the way that compiler deals with precedes. In the future, it may not need that actually. So we dimension size as t vector 2D. I don't know, run through the thing and fill it full of stuff. Size. We allocate this t vector 2D me loop. Caps lock is driving me nuts. In our X, we're going to have some, I don't know, 1,000 plus loop value or something like that. And then we'll say the Y is 2,000. That'll do us. Okay, let's get rid of. No, I won't get rid of that. I'll leave the code there so I can post it up on the forums later. I'll just push that down the bottom. So make sure I put an end at the end of this thing. I'll reuse some of this code here. I'll grab this and we'll make a container. Oh no. My vector arrays. Let's just call it something different. Right, so we're going to make, oh gee, make, yeah, sorry, I'm pretty much rushing it and winging it all at once. Not a good. To the same thing, we'll have a random number of elements in here. So between whatever that is, 5 and 10, we'll call sync and wait key. Just give it a test run, see if we're alright. We are alright. We'll run it in debug mode. Have a look. Make integer. There is make vector array. If we click on this thing here. Oh, we didn't like that much at all, did it? No. Yeah, there might be some more gremlins in that debugger than what we're thinking. It's a bit of a bummer. The process is working. I wouldn't worry. The code actually works. It's the debugger. It was trying to look at an array that didn't exist, and there's probably no protection inside it, so that's not a good thing. Alright, so we have an integer array here, which we're going to store with 16 arrays in this case, for whatever reason. 16 vector 2D arrays. We've made our vector 2D array for the function. It's initialized the array like this, returned it, we've got our handle in here. Then we need to access these things out here, we need to make an array. Oh, another typo. Make array. Oh, mail array, that's pretty good. Make array, much better. Yeah. Oh no, sorry, I'll call this one this vector array. Same thing, it needs to know that this is a typed array, otherwise you won't be able to access the fields from it. So we need to have its in handle representation. Beyond that, we can do our thing. So I'll just cut and paste that across. My hand keeps clicking the caps lock key. It's strange how different. The keyboard looks almost exactly the same as the one I use every day of my life almost. But no. Alright, we've got. So we're running through our vector array container. We're grabbing the handle, putting it in our make array. Let's check to see if the thing exists. Get array status. If it exists, then we'll do. I might just harvest that bit of code from the bottom there. Similar thing. Okay, this vector array. So we go this vector array, the loop dot x. Yeah. Grab the y coordinate from it. Add the last character to it. What do we got? Let's try it out. Yeah, so it's working. So we've got our first array contains 1000 and 2000, which is the first coordinate that's initialized in the array, and then it's 1001, 2001, so on. And each array is a different length. So the same idea works with arrays. What this means is you can actually have structures that are nested without ever having to have dynamic arrays inside types. It's not as clean as that. Granted that's a cleaner and easier concept for people to grasp, but because you can make an array anytime you want, pass it around as handle, you can pretty much do whatever you want. It's up to you to make sure that you don't lose those handles and they don't break anywhere. And that's probably going to be the main thing. We'll try running that again. Go to variables, hit stop. We'll go to my vector. No, that one there, and we can see our vector array in the panel. Gives us the name of the array and the type, the data structure we're using. The type here is actually filled. It's actually kind of superfluous, really. It's 28. It's saying it's 28 bytes long. That seems to be wrong, actually. Another little bug has been picked up. And our bank handle is 168, which is the handle of this actual array. And each type inside the array has its own handle again. And if you have strings, they have their own handle. So everything uses these handles internally, so we can keep track of what a resource is. If we just had pointers, then it's actually hard to keep track of those things, whether it's a legal pointer or not. It's not impossible, but handles are just easier. Alright, that'll have to do with that really sort of train of thought demonstration. I'll put the code up on the boards, and you can pick through it and see if you can make any sense out of it, and see if you can apply it to your own applications. Thanks for watching, and I'll catch you some other time. Bye.